Happy back from break. Are people excited to be back from break, or are they sad and they want to go back to break? Just awkward chuckles. I want to get back to break. All right. Get and get up secrets. That's what we're talking about today. First of all, do you remember that part in James Cameron's Avatar where that's thrown me off. Some of us remember the part in James Cameron's Avatar where Jake mournfully tells everyone else that he's a traitor. This is totally screwing up my intro. Now that somebody actually remembers this part, act like that didn't happen. The answer is no, you don't remember that, because most people don't remember the plot lines of really shitty movies. Think for a second how to delete a branch in Git. You probably do this a lot, so you're really familiar with this, but let me just point this out. It's git branch -d local branch, and then you say git push origin, and then the local branch which is deleted, and then you add a colon to it, obviously, and then you push it back up to the remote, and that basically says, here's the remote branch that doesn't exist, so delete this remote branch. What I'm trying to say is, much like James Cameron's Avatar, Git doesn't make any goddamn sense. Apologies for the Avatar fans in the audience. It's very pretty. Although I saw it in 3D, so it was like, I saw this stuff was very pretty, and then all the stuff in the background I couldn't actually see. Anyway, so this talk is going to throw a lot of stuff at you, not unlike James Cameron's Avatar. I have a lot of jokes about Avatar, I apologize. But this is a talk about learning the bits that make you more productive. Every now and then, I'll have all these talks that are kind of devoid of actual content and very floaty and stuff. That's not this talk. This talk is a lot about just throwing stuff up, and hopefully everyone in this room will take something back to their development team that will improve their lives with some weird trick of Git that they never knew before. It's one of those talks that you may be seeing a slide up there and you're like, I don't understand, why would I ever possibly use this? And then your neighbor next to you is hurriedly scribbling down because that totally changes their workflow for the weird edge case that they have to deal with on a day-to-day basis. So really think about this and think about how it will work for you and how you deal with Git and how you deal with GitHub on a day-to-day basis. And that's what I want you to take out of all this stuff. So I'm Zach Holman. I'm Holman on GitHub, Holman on Twitter, and I work at GitHub. I've been there for 3.5 years, and most of all of this stuff in this talk is just stuff I've learned through osmosis. I've dealt with a lot of support requests, a lot of weird parts about Git, and I just wanted to say all the cool stuff about Git because I think it's fascinating. First of all, I wanted to say, this is a Ruby conference. Most of you people know what Git and GitHub is, but for those of you who may not know what GitHub is, it's kind of a technical topic. It's helpful to sort of go back sometimes and figure out what the dictionary of, what a concept is. Luckily, someone made an infographic some of you may have seen last week that helps us describe exactly what GitHub is, and it was on Fox Business News. So obviously, the repositories are big chunks of code that can be edited by GitHub members. Forked is the term for code editing, like I forked your code. And pull request is an e-note. Pull request is an e-note sent to the original code writer requesting edit rights. Obviously. So, I was a little bit facetious. This isn't about Git and GitHub secrets. This is mostly about e-notes and how to deal with e-notes and doing everything you can with e-notes. Okay. This is going to be a very confusing talk. First part is about Git. We'll talk about Git, and then we'll get to the GitHub part afterwards. This is more Git and GitHub secrets, little bite-sized pieces of tasty morsels of all these little things that I've learned, but this is actually more because I did a talk about this previously, so this is sort of step 2. It's more adjectives, more exciting, more flamboyant, more awesome. So let's get right into it with Git stuff. And first of all, merge strategies are the most exciting thing I could come up with at the start of a talk. You probably know or have seen these types of things a lot. When you're doing a merge in Git, you'll usually see something like this. If you're merging one head, like one branch into another branch or a commit into another branch, Git will do that merge in a strategy called Recursive Merge. If you're doing multiple heads, multiple branches, or multiple SHAs all at once into one branch that you're working on, it will use what's affectionately called an Octopus Merge. These are probably terms you've seen before. You don't actually know what that means. Basically, this is just a strategy Git uses to line up different pieces of code and figure out, well, which should be the actual state of this code that you're trying to merge. The cool thing is that you can actually dictate to Git what specifically, what strategy it should be using in this particular situation. So there's a lot of weird edge cases that become awesome if you're able to do this. One of these is the hours strategy. This is basically saying, give me master, but my final state should match my current branch. This is really good for when your long-running branch will supersede master. For example, I'm working on one project now that is sort of a big rewrite, even though everyone says don't do the big rewrite. So we did a big rewrite, and we've been doing this for like months and months and months, and we have like maybe 10 commits on master because we're just sort of done with that. What is really happening is what's happening on the branch. So I don't really care anything about what's on master, all those changes that's happened subsequently, but I still want those those commits in my history to go back and see what actually happened in that time. So in this case, I can just say, well, put everything in this case that's on master and then merge it into ours, and just say that whatever branch I'm looking at is the one that is canonical, the one that I actually want in the result. The recursive, as I said, was a default strategy for a lot of things, but recursive takes like a whole bunch of options. And if you're interested in this stuff, definitely check out the man pages because there's a bunch of things you can do. One of which is passing in an option called the patience option into the recursive merge strategy. This is basically better line matching for logical groups. How many times does this happen? You have like a hash and it's very simple, blah, 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 and then you say, all right, tomorrow I'm going to do something new. I'm going to add a feature. Ta-da! That's I don't know. I was going to make a horrible joke, but it was really stupid and only funny to me. And then what happens is Git says, okay, you just added this. And you're like, no, I didn't add that. And like, the fact that Git is saying this harms nothing in the grand scheme of things. This is the most dumbest thing ever, but as programmers, this inherently makes us angry because it's like, I didn't actually add that. I added this. Why can't you just know this? So this is what it does. By passing in the patience into the merge, you can actually see it spends a little bit more time trying to figure out which brace should attach to which brace, which merge, or which you're actually trying to do. A lot of people can set this as a global option to make sure that this is going to happen all the time. Again, check out the man pages. All this stuff, like Git has fantastic man pages. And look at merge strategies because there's pages and pages on all of these certain types of things. And merge strategies are fantastic when it comes along once every couple of months. But if you don't know the particular merge strategy that would just fix all of your issues, you can blow 5 or 10 minutes trying to do this stuff all manually. It's a real pain. The next thing that I found was really cool in the last year was something called the second order diff trick. This is from a blog post by Tom Mortell, and the link is up there, and the link is in my slides later. But he had a really interesting problem that I've run into a whole bunch of times, and I didn't really figure out, I didn't even know there was a better way to do this sort of thing. So his goal in this particular situation was to transform strings with a regex in his project. So think, for example, you're renaming a module or a class or some method, and it's used all about your project. And obviously what you do is you'd rerun git diff and git reset until the regex is correct. So you'd run the regex, run the git diff, and say, oh yeah, that looks correct, and then, oh, that's not right. Go back to the reset, run it again. The problem is that it sucks to review the diff every time. And every now and then when you do those really massive find all and replace, you end up doing, all right, the top 50%, you have to go over and over again, like, yeah, I know this is fine, oh, this is that edge case I missed, go back and do it again. So Tom's idea was basically you stash what you've just checked, and then you diff against the head of that stash. So for example, say we're on a clean branch, nothing's happened, totally clean, and then you run this whatever script, or find and replace in all, and then you have some resultant output. So you run git diff, you review and check out that output, say, yep, that looks good, yep, that looks good. Nope, this is like wrong, I missed a period on here, this should be something else. So rather than resetting, you just stash it, and then you can stash that reviewed diff, run that regex again, and then you diff it directly against the head of that stash. And then this will just show you what you currently have versus what you've already seen previously in that diff. This is just great because you can find and replace projects without worrying. And that's like my biggest fear is that you're going to do like a find and all replace and commit it and then ship it and it's totally fine and then you've missed something up and then exceptions happen and it's really depressing. So I thought this was a really cool idea and it sort of plays off the fact that you can diff against the stash and that's really cool. You can do these sorts of things in Git. I thought that was really fascinating, a really important part about Git that I liked. Also important about Git, important thing about Git, emoji diffs. And yes, this is important because emoji is probably the most critical thing that's ever happened to our industry. Turns out Git diffs Unicode pretty poorly. If I run this on a file that I have, it says like, oh, mindless couple about to behead child, and then it's like u+1f. I don't even know what that means. Like, what is this diff actually trying to do? It turns out this is not really Git's problem, it's Less's problem, because Git uses Less as, by default as its pager. So as you're paging through these results, Less doesn't really know how to deal with Unicode, so it just prints out the raw stuff. There's a bunch of different ways I found to get around this. The easiest way is just say -- no -pager, and then pass that into diff. And then you can see, oh yeah, well, that's the actual emoji. That's the actual emoji. That's the actual emoji. And you're thinking here like, wow, what Apple designer decided to illustrate like an emoji that is that terrifying? It keeps me up at night. Git strip space is really cool. I like to say this fixes all your horrible coworkers and contributors to your projects. Every time that somebody commits bad white space is just terrible, terrible, terrible. So Git strip space strips all of the trailing white space, it collapses new lines, and then adds a final new line to all of the whatever file you pass it. So you can do it in a bunch of different ways. Or you can just pipe it straight into Git strip space, and then it will print it out totally fine. No more problems with white space. You can run this in your editor after file saves. I know a lot of editors, like Sublime, I think. A lot of them have settings to do this automatically, but if you're in a weird IDE, you can just shell out to Git strip space and then let it do it all for you. No need to do it all manually, because we're programmers. We don't do things manually. Git diff -- check. If the other one was more to fix your horrible coworkers, this is more to fix horrible you. Because you can't be on a pulpit and say, like, white space is bad, don't do it. And then, like, you have white space in your own code. So if you run this, it'll just show you, well, you have trailing white space here. You should probably do something about it. Or, you have a space before this tab, and you have sort of mixed mode white space here. You should probably fix that before you commit that. Kind of a nice way to make sure that you're not part of the problem. Git diff -- cached is something that I probably should have known years ago, and I'm embarrassed to say I didn't learn about this until like a year or so ago. You've probably run into this before, where git diff only diffs unstaged changes. So if you already staged something and you haven't committed yet, git diff won't pick that up by default. It will show staged but uncommitted changes if you pass it git diff -- cached. I don't know why they called it cached. It's the weirdest thing ever, but it's Git. Hot trivia break. I can only talk about Git for so long before I start getting bored, and I like trivia because it like wakes people up. It's the end of the day. Question, which of these commit messages actually happened on github.com? Number 1, a reasoned argument citing sources. Or number 2, a 500 megabyte database dump. If you said 2, you are correct. This happened from a support request that was like, why is my repository slow? And apparently if you shove 500 megabyte database dumps directly into your commit message, probably not something Git was built for. I don't even know how they did that. It must have like shelled out or something, or I don't know. Don't do that. All right, back into it. Git merge -- abort does as you'd expect. This is something else that I didn't really know for a really long time. I would always go back and like do it manually. I'd be like, oh, I'm going to do this merge, I'm going to do this merge. I'm like, oh, I messed up, let me go back. And then I'd like check stuff out, and which is really stupid of me. Yeah, Git does it for you. It aborts a conflicted merge. It resets your tree back to what happened before you started that merge. That's great. It saved me an embarrassingly amount of time once I figured this out. Git merge has a bunch of other options. You can just pass it like a message, just like you do on commit itself. It just populates the merge commit with that message. Kind of nice if you're scripting a bunch of stuff and you know there's going to be a merge and all these sorts of things. Nice to know you can actually do that. You can also pass it -- no commit if you don't want a commit message in your merge. I don't know why you'd want to do this, but you can do it. Git lets you shoot yourself in the foot sometimes. Git status -- ignored. This shows the status of everything you're ignoring. Typically what you want to do is look in your .gitignore file in a project repository. And that's great, but you can have a lot of globs and a lot of wildcards where you don't actually know what files are actually being grabbed by that gitignore. This just prints out everything that is being currently ignored in your project. This is helpful if you're like shipping off a bunch of code to, if you're on a contract and you're shipping off to somebody else and you have a bunch of like credentials and stuff in there you want to strip out before sending it to someone else. Nice, easy way to do that, and then you can just, RM all this stuff. Assume unchanged. You can temporarily ignore a file. Again, you usually put this in a .gitignore, but sometimes you don't want to commit that back upstream. If you have some weird monkey patching locally, or you have something that's not ready yet, you can just tell Git, don't worry about this file yet. Just ignore it. You do that by running update index. You pass it the path to the file, and then that will ignore it. It won't show up in git status. You won't have to commit it. You won't have to do anything. And you can reverse that by saying -- no assume unchanged, and then you'll be set. Proper git commit messages. Turns out Linus, he has thoughts on a lot of things. And one of them is commit messages. It turns out things like this is not what he had in mind for really good commit messages. And, I would never do this. Well, I haven't done it today yet. But, this is not very helpful for a lot of times. So it begs the question, like, what is a good commit message? And there's a lot of really good documentation about this. A bunch of different blog posts. The Git help docs themselves have a bunch of documentation about all this stuff too. But in short, it's basically looks like this. You have a short summary with basically it's just a title of that message that you're changing. That should be less than 50 characters. And then a line break, and then you say a longer description of the change. This can basically go on for pages. I've seen a bunch of them with benchmarks just pasted right in, and it's fantastic to look at. I love proper messages with just 2-line changes, but a whole bunch of reasons why they actually changed it. And that should usually wrap around 72 characters. The problem that I always face is when I would do this, I jump into Vim, and this would be my commit message, and I don't want to do stuff manually, right? It turns out git commit helps you write these perfect messages. Ideally, when you start typing, it should just be orange until you get to 50 characters, then it should change colors to white right around 50 characters. And then at that point, it should just start word wrapping right around 72 characters. There's a couple different ways to do this. One, this assumes your editor is Vim. You can probably do this in Emacs as well, but the drawback there is that you are using Emacs. I'm just kidding. I mostly do that for the reaction. It's like, yeah, no. I don't know. So you do this as you would expect. Your editor is Vim. And it assumes you have syntax highlighting on in your vimrc, so you just set syntax on. And then it assumes you have plugin and indenting on. So in your vimrc, file type indent plugin on. And that's it. And then every time you open up Vim to write a git commit message, it will sort of guide you there and let you do all the fun git commit message stuff. So that's all the Git stuff. I want to talk a little bit about GitHub stuff because we built the damn thing and we put a lot of cool stuff into it, and then we tell nobody, which is horrible on our part. I don't know. So let's just jump into that. Canonical URLs is kind of cool in very certain circumstances. So say you're on a README of a project, and you say, wow, this README is really cool. I want to tweet it out, or email my team, or do something with that particular URL. Usually the URL looks something like this, user/repo/blob/master/readme. The problem is that's not very future-proof. So if you press Y anywhere on any page on GitHub, we're going to give you the canonical URL. We'll just change the URL to, instead of just saying master or the branch name, it'll just say the SHA. This doesn't have to do a page refresh or anything crazy like that. You just type Y and then you're done. And the benefit here, obviously, is this won't change even if the branch does. If you're ever on Time Hopper, one of the apps that let you look back in time on what you've tweeted in the past, all of my links from 5 or 6 years ago are completely broken at this point because the internet changes, I guess. This will help to make sure that what you tweet out will, stay the course of time. Curlable public keys is kind of a nice little hidden feature. github.com/user.keys is the list of your public keys on GitHub. It's cool because it's plain text, you don't have to authenticate, and it gives you access to somebody's public keys. This is not an API. Even though APIs are really fun and stuff, that means you have to, figure out a library usually, you have to authenticate, you have to worry about rate limiting and stuff. This, you can just curl it, and then you have public keys. You can programmatically add SSH keys. I know a lot of people use this when they have a listing of all of the users in their dev team, they're setting up a CI server, or any sort of server, and they can just programmatically run through all of the keys and then just add them to the server and then they're done. Kind of a nice thing to do. Some people get worried because their public key is now public for everyone. It's a public key, I don't know. Encryption. Fetching pulls is really kind of interesting and something we've really not talked about at all. Think about the process that happens when you accept a pull request on GitHub. You have to add a remote. If you're sending me a pull request, I have to add your remote to my repository. I have to fetch your branch into my repository. I have to merge it, and then I have to push it back upstream. Anytime you have to deal with remotes in Git, it's just a lot of added overhead, and it's a lot of pain. It's a lot of boring commands. As a side note, GitHub stores all of the pull requests you've ever done against any repository in that particular repository. This means we do this because we can track code even if you delete your fork. I mean, think about that. It happens a lot where you're just like, oh, typo in this README or whatever. Send a quick pull request, and then it gets merged, and then you just want to delete your fork and then be done with it. We still want to retain that history in that pull request forever. And we do that by stashing it in a particular spot in your repository. So we abuse it, and you can abuse it too, which is really cool. So if you're just saying git fetch origin, pull ID head name, or for an example, pull /12/head :PR, again, the great Git syntax. But this will pull the pull request number 12 into a branch named PR locally. You don't have to add any sort of remotes. You can just pull normally. And this is cool because I know a lot of people will run helper scripts and they will do this again on like CI. Well, they'll just automatically pull down all the pull requests when they first clone down the repository. It's just a nice sort of step past all of the drudgery around setting up a remote. Live updates, pretty self-explanatory. On an issue page, if you haven't seen this yet, you can just sit it open, and then comments will come in, merge stuff will happen, more comments will happen. It happens all on the page. We just push it using WebSockets, which is a new technology I hear. It's pretty cool. Second and final hot trivia break. I love these things. Most frequently used emoji on GitHub. Because again, I love emoji irrationally. Number 5 is clap, which is kind of nice. Because, it's kind of a positive thing. Like, yeah, nice pull request. I like it. Number 4, also really cool, +1. People, really like this. It's nice to have this sort of positive feeling in the developer atmosphere. Because people aren't that very positive too much. Number 3, crap. Number 3 is -1. People don't like that. Number 2 is sparkles. I have no idea why this is so high. Apparently, like a lot of people, maybe it's just too committal to be like thumbs up or thumbs down, so they just throw sparkles at you and then, it's fine. I don't know. And number 1, as you might expect, ship it. The ship it squirrel by an ungodly amount, so much more over all the other emojis. Everyone likes to ship it, I guess. I find this stuff interesting. Just put it like a giant squirrel on a screen in a conference. Amazing. Quick quotes. If you use Markdown a lot, we use Markdown all over the place on GitHub. Markdown uses, I don't know, caret or whatever, angled bracket. Is that the correct pronunciation? They use that for block quotes. So if you're quoting somebody in line and you're having a discussion with somebody, you just add that and then their thing, and then we'll make a block quote. We simplified this slightly on GitHub. So instead of having to do that all manually, you just highlight the text and press R, and we'll do it for you. So highlight that text, press R, we'll drop it down there. I do this a bunch if I know I want to respond to like 6 different things in a particular issue, and I'll just do that, hit R, and then it's all filled out for you in the bottom. Kind of nice. Browsing stars is kind of cool if you're into sort of browsing social networks and stuff. github.com/stars/a username, in this case Brian's. And you can see all of Brian's stars. This is kind of cool if, you want to know what is the next hot thing. It turns out it's Go. I've looked on the internet. Go is apparently, Ruby is not cool anymore. It's all about Go. Node is right out. I don't know. Webflow. I want to bring up Webflow a lot too because even though, I'm a developer, but I use this a whole bunch. You can do a lot without leaving the browser. And I love that because you don't have to clone down a repo and deal with all that sort of stuff. So really quick, one-off, easy things that are kind of brain dead, like you're going to do them anyway. Like quick documentation fixes, prose fixes, switching away from inferior databases. You can do that all on the web and not have to clone down the repository and do that yourself. So in the branches tag, you just keep typing a particular, name, and if the branch doesn't exist, we'll say, would you like to create this branch? And you hit yes. You create that branch, and then you can create a new file in that branch, paste in whatever you want to deal with, and then hit save. Now there's a new file on that branch, and then we'll ask, would you like to do a pull request for that branch that you just made? And you click yes, and then whoever's trying to merge that pull request can do it, obviously, with the merge pull request button, and then they can delete it. I just want to point this out because it frees you from git clone. Like, git clone is, it seems like a very simple thing, and like, oh yay, now I have all the history, but for a lot of stuff, it's just not needed. And for me, it's very easy to just jump in and just do all these quick changes and not have to deal with, Git cloning and stuff. Issue autocomplete is a fun little thing you've probably run into before. If you type the hashtag, is that what we're calling it now, the pound sign or something, you get a quick search. You probably ran into this already, where it just drops it down. But the cool thing here is that you don't have to type in issue numbers to actually associate the issue. You can just type in full text search. So in this case, I'm typing in Rails, and then it can search through the actual titles and bodies as you would a normal search. And then hit enter, and then we'll translate it back into the numerical issue ID. And then once you hit save on the issue, this is GitHub flavored markdown, so we'll link that up in the issue and create a reference between that issue and the other reference, so you can know those two are linked. A quick little tidbit on that. Repo Redirects are a couple months old at this point. Does as you'd expect. It renames your repository, and GitHub will redirect all of your old URLs. This is good if you care about, SEO optimization or whatever the cool kids are doing nowadays. And Repo Licensing was also something that we sort of added a few months ago. And that was kind of cool. So when you create a new repository, you have a license selector. That's awesome. The cool thing is you can also add licenses to existing repositories too. For all of those repositories you have out there that are unlicensed, go back and license them. And you don't have to go in and copy and paste and do all this sort of stuff. Just create a new file using the web editor again. And then for the file name, just type out license, and then we'll just show up the license, or we'll make the license selector appear right on page. And you can do that. This also works for .gitignore because we have an open source repository, GitHub/gitignore, I believe, with a whole bunch of gitignores for Rails or C projects or anything like that. So just type in gitignore, and then we'll pre-populate all of that stuff, and you don't have to paste all that stuff in manually. File Finder is, I keep wanting to add a button for this, and I just never do. I use this literally every day. Does everybody know about the File Finder, by the way? Amazing. Some people don't. For those who don't, type T. That's it. This is just like Command T on TextMate. If you type T, it's a fuzzy search. It searches through all the files on that particular repository. This also works on branches or on a particular SHA. We'll scope it to that, so you can just type T, type in your little fuzzy search, hit enter, and then you get dropped right into that file. Super helpful, especially if you're a Java person and you have like 800 nested hierarchical directories for some reason. I guess they do that in Java land. Task lists came out sometime last year, I believe, or this year. You can use issues and pull requests as to-do lists. We found ourselves using this inherently just on stuff on a day-to-day basis at GitHub. We would sort of say, okay, this is what I want to accomplish in my pull request, A, B, C, and D. Cool. But you can actually do this, now we support this directly in the issue. So if you have this sort of syntax, dash, space, and then brackets, and then you can say, these are the things I want to do. I want to use NewSQL, use today's trendiest language, do all this sort of stuff, and then finally profit. When you type that into an issue, we will translate those into actual checkboxes, and they're workable checkboxes. So you can check all of those things, and then now you're almost on your way to making a successful startup. The cool thing under the hood, we just use this as plain text everything. So it will just put in X's. So if you start out, this is the final syntax for when you've completed a particular task list. The other cool thing is that we put this on the actual pull request listing. So we use this a bunch. If in this case, I have 5 tasks, I've done 4, 1 remaining. This is a quick glance to figure out, well, is this pull request all the way, is it far along? Is it really far away from shipping? Kind of a nice little quick glance at different things. We have a lot of task lists internally on our GitHub pull requests. Fork URLs. You've probably seen this button a lot. It's apparently a big deal on GitHub. As you might expect, and you've probably done it before, it pops up a little modal box saying, where would you like to fork this repository? There's also an actual permanent link to this too. So user/repo/fork, and it gives you this HTML page. The only reason I bring this up is for README links. Because I do this all the time in an open source project. I'm like, in the README, I'd say, well, why don't you fork this and then do all blah, 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 and fix all my bugs. You can actually just hyperlink it straight in the README and save everyone an extra click. Kind of a nice little tiny thing that makes things better. So that's mostly what I had for you. Just remember, Git is probably terrible. And I say that as someone, Git pays my salary. I love Git. I think it's one of the most impressive technologies ever, but it's really confusing. But I think the reason it's so confusing is that it has a lot of power behind it. It's a really cool technology at its core. And literally, if you're spending a lot of your time working on Git, you owe it to yourself to sit sit down in the man pages and look at specifically what your options are available to you. Because you're not wasting time adding stuff and committing stuff. Even though you do that stuff 90% of the day, that's not where your time sink is. Your time sink is on these weird merge commits that take like an hour or two trying to sort through all this sort of stuff. And Git has a lot of power under the hood to help you out with that. So spend some time and look into this sort of stuff. It will save you time down the road. Thanks.
Does anyone have questions for Zach? You do have time. Okay. Uh-oh.
So on a pull request, if I click into a tab to look at the actual the diff, why can I not hit back to get back to the actual pull request text and comments?
Wait, what was that last part?
Why can I not hit back on the browser to get back to the comments?
So we go back and forth on that internally a whole bunch. When I'm trying to remember what the actual... So hitting back goes back to the full pull request listing, right? Yeah. I don't know. I didn't build it. No, I think the rationale is that it's not an actual separate page. It's more just switching tabs between on that page. So that's the rationale. That's why we don't add a history state to that particular page. I know it's come up a number of times, and that will probably, I don't know, get tweaked or revised at some point in the future. If it sounds like it's something people have else run into as well. All right, let's make some changes. Yeah, I don't know. I'll see what I can do.
Cool. Oh, one more. It's a lot of workout today.
Are there any plans to stop including pull requests and issues?
What was the first part? Sorry.
Any plans to stop including pull requests and issues?
Stop mixing them?
Yeah.
We don't comment on future plans.
It's a good answer.
Probably not.
All right, cool. Thanks, Zach.